Good morning, everyone. Welcome to this video lecture. We are going to wrap up our review of Java today. We are going to discuss about the last quote-unquote hot topics, which are the things that have been causing trouble to students in the past semester. So I tried to condense them all in the last lecture. So up to today, the lectures have been reviewing the syntax of Java a little bit and going over some tips and tricks on how to write programs from scratch, trying to get everybody on the same page, on the same level. Now we're going to look at more specifically technicalities of Java that are often misunderstood by students. So without further ado, let's jump into the slides. There we go, or not, maybe not. We were not going to jump into the slide. There we go. Yes, we are. All right, so let me grab the laser pointer real quick. Here we are. So let's talk about things that go bump in the night, things that are not really always straightforward to understand. So I already talked a lot about data types in Java. I mentioned them several times. I mentioned the fact that we have two different families of data type. On one hand, we have the primitive data types. On the other hand, we have the reference data types. And I kind of gave you an informal definition of them. So just to recap a little bit here very quickly. So as far as primitive Java data type, these are the data types, that start with a lowercase, like int, long, char, boolean, and so on and so forth, okay? Everything else, I would say, is a reference data type. So everything that starts with an uppercase, like string, scanner, represents the name of a class, that's going to be a reference data type. So when you declare a variable of type scanner, you declare a variable that is of a reference data type. Now, there is a little bit of an exception here. What if I have int square brackets, empty square brackets, my data? Well, that's a name of data type that starts with a lowercase, right? Int, the same as the primitive data type. However, as we are going to see in a few slides, this is also a reference data type. The rule being here that all arrays in Java are reference data types, okay? So that's kind of like the big picture here. The main difference between primitive and reference data types is when you declare a variable that is of a primitive data type, the variable holds a value. For example, your int data that is 42, 42 is stored inside the variable that you named data. What else? Double x equal 10.3. The value 10.3 is stored inside the variable x of data type double. When we talk about the reference data type, it's a totally different story. The reference data type, all of them are just meant to hold a reference. Think of it as a memory address, okay? So whether you have a reference on a scanner, a reference on a string object, a reference on an array object, an array of integer, or an array of double, or an array of arrays of arrays of arrays of scanners, no matter what you are referencing, the size that it takes to store a reference is always the same. No matter whether you are sending a letter to a tiny little apartment or a huge mansion, the room that it takes on the envelope to write the address should be roughly the same, right? So this is kind of the idea here. Now, when we have those reference variable, right, we don't store the value itself. Like, for example, if we have a reference variable on a scanner object, the scanner object is not inside the reference variable. Only the address of the scanner object is inside the reference variable, and the scanner object lives a happy life completely elsewhere in memory. Okay, so there are a little bit of a few fine points there that we are going to go over during the semester. We covered those in 2512, so if you have been doing your reading assignment, you know already that there's a little bit more to the story. But for the sake of this review, I'm going to kind of glance over it right now, and we are going to come back when it becomes relevant in COP 2513. So going back to the slides, I think I covered everything here. Why is this relevant? Why this difference that seems completely arbitrary? And by the way, some programming languages do not do things like that, okay? So why this difference, and how does it matter? Why does it matter for us, okay? So we're going to talk about what we just mentioned about data type, primitive and reference data type, in the context of parameters and argument for methods. So let's take a very simple method. I love this method. It's very simple. Everybody understands what it's supposed to do. Everybody expects it to kind of work. And then we realize that it illustrates a kind of a nasty little thing in Java. So let me not spoil it for you. Let's dig in. So we have a main method here. So we have defined a class, whatever name we want to give it, okay? Inside that class, we have a main method. That main method declares two variables A and B. They are variable of data type int, so that's a primitive Java data type, okay? The first one is initialized to 7, the second is initialized to 35, and then we call a method that we are going to provide, okay? We're going to write the code for that method like in like literally 5 seconds. So we call a method named swap, and we pass to that method two arguments, which are A and B. So the first mistake that people make here is they look at this and they say, oh, you're calling the swap method and you are passing to the swap method the variable A and B. Wrong. We cannot pass variables in Java. What we pass is values. Okay, so that's the point that I'm going to focus on illustrating with this example. So what are the values that I pass when I call the method swap? Well, the values that I'm going to pass as respectively first and second argument are given to me by the expression that are here. There we go. And here on both sides of the comma. So the first expression, I'm going to evaluate it, is going to result in a value. That's the value that I pass as first argument. The second expression, I evaluate it. It results in a value. That is the value that I pass as second argument. So in this case, our expression is super simple. The first expression is just A, so a simple variable name. How do you evaluate the name of a variable? Well, you just look inside that variable for the value it holds, and that's actually the result of the whole evaluation. So there is a 7 in A. I'm passing as first argument here, 7, comma. Second argument is B, so that's an expression. It's just the name of a variable. I'm going to evaluate it. B contains 35, so the result of evaluating the expression B is 35. I'm calling swap with the values 7 and 35. Okay? And now what I want to do is I want my swap method to be able to swap around the contents of the variable A and B. So the idea is that it's not going to work very well, and that's going to be the point of this lecture, right? Why doesn't it work very well? What can we do to make it work, okay? Well, what's interesting here is that we are trying to make it sound like I'm going to call swap, the swap method on two variables, which we know in Java we cannot pass variables, okay? We pass values, but I'm going to call it on two variables A and B, is going to swap their content, and then I'm done. All right, so a natural solution to that, and by natural I mean wrong, okay? That's the first thing that comes to mind, is to say, all right, I'm going to declare my public static void swap method. It takes two parameters. I'm going to call them A and B. Please note, I call them A and B, but this A and this B has nothing to do with this A and this B, okay? If you are still a little rusty on that, I recommend that you review the chapter on methods. It explains in excruciating details, what is meant by argument, what we pass when we call the method, and parameters, what we name the values that we are receiving, okay? And it explains exactly why these variables here, A and B, have nothing to do with another A and B that would be defined in another method, like for example in the main method here, okay? So make sure that you don't gloss over that. This is very, very important. And as usual, if you have questions, Piazza, office hours, and so on and so forth, okay? So I declare here my method. I say it's going to be called swap. It returns nothing. So I could decide to return one value, but here, if I want to swap A and B, there's no point in me returning anything at all. I'm just going to do the swapping, right? So here are the parameters I receive, A and B. And how do I write this? So generally, when I teach this face-to-face, I give like 5 minutes maybe to students so that they can write the code. Go ahead, pause the video, and give it a shot, okay? Try to write the simplest version of swap A and B that you can possibly think of. And then let's take a look at the solution together. Maybe I went a little too fast there. So this is like the most, I would say, naive, natural solution that comes to mind. Int temp equal A, so I declare a local variable temp inside my swap method. I assign A to it. Then I overwrite whatever is in A with the value that is in B. So right now, A and B contains the same thing. Then I assign to B what I saved in temp, which was the value of A. So now B contains what used to be in A contains what used to be in B. So I did swap the variable A and B. This code looks really correct, right? I did swap the content of these variable A and B. That's what I should have said. So the parameter A and B, their content has been swapped around. And then what? And then I reach the end of my method. I return to whoever called me. So again, if you have done your reading assignment, you know that that means that here the parameter A and B are going to disappear from memory because they are no longer in use. They appeared when I entered the method swap. They disappear when I exit the method swap. They are temporary, just like the local variable here, like int temp. Okay, these are all variable temp A and B that are used during the execution of this method. But once I'm done, I get rid of all that memory. I reclaim it. Okay, and so I come back here, and then what? Well, that A and B that got swapped around now disappeared from memory. I come back to the main. The main had his own version of A and B, and those have never been changed, okay, because I could not access them from inside swap. All right, so it looks okay, and it does actually permutate something. It swaps the content of two variables, but not the right ones. I'm going to show you two more perspectives on this, okay, and why exactly it doesn't work. So we're going to get into more and more detail. The idea here is we're going to do a trace table. So a trace table, for those of you who never did it, it's kind of like using the debugger, but by hand. We make a table. We say, okay, let me list in each of the column the variables, the parameters, the argument that I have. Will you not hit that, please? Okay. All right. We're having like electric problem. I'm going to keep an eye on him. Okay, so we have here all of the variables in our program, all of our parameter, right? And then we are going to make a row for each step of execution. So one of the common things that are misunderstood by students when it comes to trace table is they think, well, if I have a program here that has 1 up to 15 lines, okay? Well, my trace table should be 15 steps. No, it's not. No, because if you have a loop, for example, somewhere, right, you're going to execute line 1, 2, 3, then your loop starts. You're going to go over the same 3 or 4 lines, right? So that's what happens at runtime. That's the dynamic execution of your code. So a trace table is not just a list of all the lines in your code and some information about them. That would be reading out loud the source code and commenting on it, right? No. The trace table follows exactly what happens when you run your program. So let's take a look together here, okay? Here we have a control flow that is relatively linear, right? We don't have loops, we don't have stuff like that, but you're going to still see how we jump from line to line sometimes. So line 1, there's nothing to do. It's a declaration of the method main. Line 2, I declare and initialize a variable A. So I put in a column A, variable A from the main, right? I write the number of the line 2, and when line 2 is done executing, A contains 7. Similarly, when line 3 is done executing, I have a new variable B, so I make a column for B, and B contains 35. And then line 4, there's nothing. Line 5, it's a comment, nothing happens. Line 6, I call the swap A, B method. So I call the method that is defined starting at line 11 up to line 15, okay? So when you call a method, you jump to the method. What's going to happen when I enter the method? Well, again, reading assignment, right? When you enter a method, so when you execute line 6 here, you enter the swap method. We are going to reserve memory for a parameter A, this guy here, a parameter B, this little guy here, okay? A is going to receive the value 7. I explained that already at the beginning of this lecture, right? If I call with A as argument here, I evaluate the argument. A contains 7, so I pass the value 7, and the value 7 gets assigned to that parameter, which is also called A, okay? And then what? And then we have here the value 35 that gets passed into parameter B the same way. So please notice that we have variable A and B in the main, and we have parameter A and B inside the method. And these are different memory cells, right? Each of those represent a different memory cell. And then what happens? I jump to line 11, so I do this parameter passing, right? Line 12, here we are. I have a variable TMP, so I add a column for TMP. This variable TMP is initialized with the content of A. A contains 7 so far, so I assign 7 to TMP. Line 13, I assign whatever is in B to A. So here we are. In B, I have so far 35. I assign it to a variable parameter, A. So I override the 7 that was there before, okay? So now I have 35 in A, 35 in B, that didn't change. And finally, line 14, I assign TMP, which is 7 right now, to B. So now I did the job, right? A started with 7, B started with 35. The parameter A and B started with 7 and 35 respectively. By the time I reach line 15, the end of my method, okay, I successfully permutated the values in parameters A and B. So 35 is in A, 7 is in B. Perfect. And then I return from my method call. Line 7, there's nothing to do. Line 8, I want to display on the screen A and B, the values inside of A and B, but guess what? I returned from the method to the main. As soon as I return from the method, those 3 last columns here, A, B, and TMP, they go away pretty much because I'm not going to store the temporary variable that I was using, temporary variable and parameters that I was using during the execution of a method that's completed, right? And then what I have here is I'm left with A and B the way that they were in the main. So these variable A and B, you see that on line 2, I assigned 7 to A and 35 to B on line 3. That never changed. I did all that work inside the method that I call, but then when I come back to the main, they are still 7 and 35. Okay, so that's one way to look at it. That's one way to make sure that you understand exactly how code executes in Java and that you understand that chapter about method. Now, another way to look at it that is also very detailed in that chapter on method is to look at the concept of programs execution stack and activation record. So let's move this guy here out of the way. There we go. So if I run in my head again this program, okay, executing line 1, 2, 3. So what happens when I enter the main method? Well, when I start executing my application, right, Java is going to create on this area, in this area of memory called the programs execution stack, is going to create an activation record. Think of it as a bunch of memory that's locked in, that's reserved to be used by the main. So we're going to call that the activation record for the main method. So I call the main, I enter the main method, I start execution, automatically this activation record is reserved on the stack. This activation record is big enough actually to hold args, which is a parameter of the main method. So I didn't represent it here on the diagram, but it should be somewhere here, okay? And then because I have two local variables A and B, inside the main method, then inside the main method activation record, I'm going to also have enough room to store A and its value, B and its value. Okay, so 7 and 35. So it's another way to represent without a trace table, what's happening in memory actually. And this way to represent things is a little bit closer to what's happening actually at the hardware and in the process. Okay. Then I reach line 6 and I call swap. So what happens when you call a method? You enter the code of that method. Whenever you enter the code of a method, what happens? Activation record is created. So now I have another activation record. This time it's the activation record for the method swap. So I call the method swap. For that call to the method swap, I get an activation record. Think of it as I get scrap memory, I get a chunk of memory for me to be able to work while I execute the method. So what do I need to store while I'm executing the swap method? Well, I have two parameters, A and B, okay? So I'm going to have room to store the value of A, the value of B. How are they initialized? When I call the method, I call it with A and B. So A is 7, B is 35. I pass the value 7, which are stored into a parameter that is weirdly enough, also named A, but it doesn't have to be named A. And then the value 35 is stored in the parameter named B, okay, which could be, again, named whatever we want. And then I need also to be able to store in this activation record a variable temp, that I'm going to assign here to some value as soon as I start executing line 12. But for now, I just entered my swap method, and this is what happens in memory. And then I'm going to execute the rest of the code, okay? So what happens on line 12, I assign whatever is in A to the variable temp. There we go. Then I assign whatever is in B to the variable A. So the content of A changes from 7 to 35. And then I assign whatever is in temp to B. So the content of B changes from 35 to 7. So you see that we did the swapperoo here. Okay, we did our swap. But then again, I reach the end of the method, and when you leave a method, when you complete a method, the activation record for that method disappears. So all of the temporary memory that you were using to do your calculation is kind of like scrap paper, draft paper, during an exam. Once you're done with the exam, you take it, put it in a bowl, throw it in the bin, score 3 points, right? Well, that's exactly what's happening here. So now I return back to whoever called me. I return back to execute whatever comes after line 6. I'm back in the main. So we are back inside the activation record of the main, where there are only local variable A, local variable B, and I mentioned also that I should have added also the parameter args here in memory that are relevant to this execution of the main. And so when I display A and B, guess what? I display A, which is here, B, which is there, 7 of 35, still not working, okay? So these are all different perspectives on trying more or less formally to understand and to deal with the fact that we pretty much cannot swap two parameters of type int in Java. And this is true for any of the primitive data types, okay? And this is just the way that Java is wired. So this is like a hard limitation. It's a very simple task, but it's a hard limitation for Java. What I want to bring with this, I want to bring the concept of the value semantic for primitive data type. So semantic is a word that just means pretty much meaning, okay? The meaning of statement in a programming language. We refer to that as the semantic of the statement in a programming language, what they actually do, what they mean. So what do we call a value semantic? A value semantic applies to primitive Java data types, and it tells us that pretty much when you assign a variable to another, what you do is you take the value that is in the variable you are trying to assign, you copy that value, and you put it inside the variable to which you were trying to make an assignment. Okay? So it's verbose to explain in English, but if I show you some code, it's really trivial. Okay, so we're going to do that. There we go. Int x equal 5, right? So primitive data type for x, int. And then we declare the variable x, we assign it 5. Then int y equal 5, so declare variable y, primitive data type as well. So the semantic that's going to apply here is going to be the value semantic. So when I initialize y with x, I assign x to y, okay? But you know how assignment works, right? If you assign blah to a variable, you start by evaluating the expression blah. So in our case here, the expression blah is just x, the name of the variable x right here. So how do we evaluate an expression that just has a variable name? Well, you just look inside the variable and figure out what it contains. Here it contains 5. So that's what it means by I make a copy of the value, okay? Because x contains 5, I'm going to assign 5 to y, and both x and y contain 5, but both x and y represent two different areas in memory, two different variables, which contains a bunch of zeros and one, a binary code pretty much, that represent, in both cases, the value 5. But it's not because you and I write on a piece of paper the value 5, for example, that those two values are somehow magically linked, right? So we each have our copy of the value 5 on our copy of our own piece of paper, right? So if you modify one, of course, the other is not going to change. And we totally expect that with variables, right? So for example, if I assign 17 to y on the next line of code, then y is going to contain 17, of course, but x still contains 5. These are independent variables. So this is how primitive variable of primitive data types in Java work. If I assign 8 to x, then yes, x is changing. Now it was 5, it's 8, but y is still 17. But it works completely differently when we switch away from primitive data types and we go to those reference data types that I already mentioned before. So let's talk a little bit about the so-called reference semantics. So every time you talk about an object, okay, every time we are going to manipulate object, we are going to manipulate object via reference variables. Okay, so a scanner S equal new scanner system.in. There you go. We have two things here. We have a variable S, which is a reference variable meant to hold a reference to an object of type scanner. And then we have the scanner object itself somewhere else in memory. And the address of that scanner is put in the variable S, and we use S to access the scanner. For example, s.nextInt. Okay. All right. So what is a semantic when we are manipulating those kind of variable, reference variable? So when we are manipulating pretty much reference data types in Java. So when one variable is assigned to another, when one reference variable is assigned to another, what's happening is that both variables end up actually referring to the same object. Okay, it's like I have the address of a friend here. I have the address of their house. If I actually copy this address onto a piece of paper that you are holding, right? Both of us have a copy of the address. So there's still the notion of copying values, right? And as a matter of fact, it works really the same way that we describe how things work for int, for double, for float, etc. So, but this time, instead of copying a value that is a numerical value or any of the primitive data type, we just copied an address, and that changes everything. Because when you have just a value like 5 or 42 or 23 or 8 or whatever, right? If you change it, well, you change it, that's it. What if you have an address? Well, again, if you change your address, well, everybody can change their address separately. So to use the analogy of writing addresses, of people's houses, on a piece of paper, if I have an address written on a piece of paper at dictate it to you, you copy it on a piece of paper on your own. If you decide to burn your piece of paper, then that's fine. Mine is not going to burn magically. If you decide to change the address on your piece of paper, mine is not going to change. So we still have that value semantic deep at the fundamental level. But because you and I have copied special values that are addresses, that are references, right? What we can do that we could not do before with primitive data type is we can say, well, I have a reference here. Let me follow that reference and go figure out what I can do to that object over there in memory. And I already mentioned that when you have like reference variable, okay, you assign one reference variable to another. You take this address, you put it into the other variable. Now both variables have the same address, meaning they refer the same one unique object. And if one of them decides to do something on that object, the other one is going to immediately see the change as well. Does that make sense? So let's take a more concrete look. Okay, this is a first level explanation, trying to explain it as non-technically as possible. You're just using plain English, but then we need to put a second layer of paint on your understanding of the concept and dig into the actual code. So we have here a declaration of a variable A1. A1 is declared as being of data type. So read it right to left. Okay, A1 is an array. This is the meaning of the empty square bracket here, an array of int. And this is why it's a little bit deceptive here, is because int is spelled with a lowercase I. So you could tell me, well, I know my lesson, right? Like lowercase mean primitive data type. So A1 is a variable that is declared of a Java primitive data type. Wrong just because of those square brackets. Okay. The square brackets change everything. They mean it's not just an int. A1 is not a variable of data type int, which would be a primitive data type. It's a variable of data type array of int. And even though we start writing it with a lowercase letter, okay, and most reference variable, if not all reference variable except those, are going to start with an uppercase letter for the name of their data type, well, it's still an array of int. And every array in Java is actually an object. So we are talking about a reference variable here. That variable A1 is declared to be a reference variable meant to hold a reference to an object, which is an array of int value. It would be the same thing if we had an array of double, an array of float, an array of long, and even if we have an array of things that are themselves, reference data types, like an array of scanners, an array of strings, to use the two examples that we have been using so far. Okay, and then we're going to talk about when we have arrays of arrays, which is multi-dimensional arrays. Okay, but all of those examples mean simply that I have a reference variable to start off with. So here I use that shortcut notation that I explained last time, right? And that shortcut notation here is saying pretty much, I want you to create an array. This array is going to have 3 elements, okay? And those 3 elements are going to be 4, 15, 18. So that simple use of a curly brace, notation does a lot of work for us. It creates an array, it populates the array with values in each of the cells of the array, and then once that array object has been created, it returns the reference to that object so that it may be assigned to variable A1. Okay? So the diagram here represent what happens in memory. It's very useful for you to picture those kind of things as diagrams like this, okay? And draw them. When you're not sure what your code is doing, draw those kind of diagrams on paper as you read through it, as you trace through it, to make sure that you understand exactly what's going on. So here comes my variable A1, my reference variable A1 right here. So it lives here in memory somewhere, okay? It contains a reference. And when this line is done executing, I created an array somewhere else in memory. This is my object of type array of int, okay? It's large enough to hold 1, 2, and 3 int values. The first one will be a 4, the second a 15, an 8. So this is my object of type, array of 3 int, pretty much. And I put the reference to that object inside A1. So A1 refers to that array object, points to that array object. Okay, when you take COP3515, you're going to play with a C programming language. A C programming language doesn't have references, but it has pointers, and pointers are kind of like a low-level version of reference that actually allows you to do a lot more. You can do even arithmetic with those memory address. You're going to discover all that. It's going to be fun. But for now, Java allows us to do very few things with a reference. We can store the reference of an object in a reference variable, and then we can use that variable to go at that reference, to go at that location in memory, find the object, and interact with it. Okay, that's it. And that makes Java actually a simpler language to program than C. All right, so that's just one variable and one array. But what if I declare a second reference variable, A2? A2 is an array of int, okay, always read right to left. A2 is declared as an array of int, and I initialize it by assigning to it the result of the expression, evaluating the expression A1. A1 is just the name of a variable. How do you evaluate a variable? You look at what's inside of it. So this is what's inside of A1. And in this case, it's a reference. And that value is what you assign to A2. So that reference that we have here that tells us where to find this object here, this array object, is going to be copied inside of A2. All right, so both A1 and A2, as you can see with those arrows here, both A1 and A2 now are going to point to the same object of class array of int. All right. Okay, so going back here to the next slide now. What if I want to access that object? So a reference variable I use to access objects, the objects that they refer to. So what if I want to use the reference variable A2 to access my array object, and more specifically access the first element in that array and change its value? So change the value that was a 4 before into a 7. Well, the notation is like most programming language using this notation for arrays, right? A2, the name of the reference variable, square bracket, and between the square bracket, you specify the index. So I want to access element index 0. So A2 square bracket 0, index 0 inside A2, A2 index of 0, whatever you decide, however you decide to read it, A2 of 0 or something like that, then it's going to be changed and assigns the value 7. So this expression here represents this element here. A2, find the object, index 0, that's the first element, that's this memory cell here. Okay, and I assign a 7 here, which replaces the 4 that was originally there. And that's it. So you see that I could have used A1, I could have used A2 to access the element, and that's going to work. Proof that it works actually, and the same array is modified. When I go back here and I say I want to system.out.println, pretty much I want to display the content of the array that is referred to by A1. So I use a little nice trick here, arrays, uppercase A, so that's the name of a class in Java, dot toString. So I call the method, the static method toString from the class arrays, and I give it as parameter a reference variable that refers to an array of primitive data type. And what it does, it's going to return a string that I'm then going to pass to system.out.println, and that string is going to be used to display actually the content of the array. So the string represents what's inside the array, and by convention, the way that toString works is that it's going to give us a text that starts with a square bracket to remind us that we're talking about arrays, provides the value of the first element, 7, comma, space, the value of the second element, 15, comma, space, 8, and then close the square bracket. And that's going to be the text, that's going to be the string that's returned by arrays.toString, and that is then passed to println so that it displays it on the screen. So we're going to get this kind of stuff displayed on the screen. And that shows us that our array that initially contained 4, 15, and 8 has been indeed modified by using the variable A2. So it's kind of having alias, okay? A1 is a reference to that array, but A2 is also a reference to that array. Since we're talking about the same array, whether you use A1 or A2 to go inside the array and change values, you are going to, at the end of the day, be able to see those modifications, whether you look through the length of A1 or the length of A2, okay? And that's different. That's something more that we could not do with primitive data type. So when does it come into play with methods? Well, you are going to hear a lot of people talk about there are two ways to pass parameters in a programming language. So here in this case, we are talking about Java. One way is by value, which refers, to the value semantic. So I copy the values, and one way is by reference. So I pass something to a method, but I pass a reference so that that method inside of its code can modify whatever is being referenced to. Let's take an example again. General explanation in English can help some of you. For some of you, it's going to muddy the water even worse. So let's look at code. This is actually completely unambiguous. So I have a method main. Inside the method main, I have a reference variable IQ meant to hold a reference to an array of int. And I use that little curly brace notation here to create an array of 3 int values, okay? And I pass the reference to that array inside the variable IQ. I call increase, a method that I'm going to write. I pass as argument IQ, which means I pass the reference to that array object. Now, because my method has a reference to an array object, and it decides to call it parameter A, okay, it can actually use a loop, query using the A reference variable, the length of the actual array that is being referred to by A, then iterate over it, index, from 0 to the size -1, and take the element, the value inside the array at element index I, multiply it by 2, and replace it with this new value. So I'm modifying my array here. I'm taking every element inside the array. Okay, for every index of the array, I consider that element at index I, and I replace it by its current value multiplied by 2. So I take every element in my array and multiply them by 2. When I'm done with this method, something changed in the main this time. Something changed in the main because what I gave to the method was, it was still a value, right? It was a value, but that value was a special type of value. It was not a primitive data type, okay? It was actually a reference data type, and giving a reference to somebody allows them to find whatever you are referencing. So because I gave a reference to my array, so this is my array here inside the main, I gave a reference to that array as an argument to the method increase. Now increase as a reference to the array, it can go and mess that array up however it please. Again, third perspective, to understand this. So first the narration in plain English to the code. 3, a little bit of visual stuff. So this is my variable, my reference variable IQ inside the main, okay? It contains, let me move this guy again, if I can. Apparently I cannot. There we go. So inside, let's move completely to the side there. So inside the main, I have a reference variable IQ. It contains a reference to an object which is an array of 3 int, okay? So index 0, the value is 126, that's the first element, then 167, then 95, here we are. And then when I call actually my method, so when I get to the point here where I'm executing the call to increase here in the main, I'm going to pass a value, which is that reference, the reference inside of IQ, to as an argument to my method, which is going to collect it under the name parameter A. So inside the method, now I have another reference variable, that's my parameter A, and it contains exactly the same reference that is here. So whatever was here inside of IQ is actually inside of A as well, which means both of them refer to the same object as the same address, okay? And now because I can access this array with the reference variable A inside the method, I use that alias to simply go inside the array, multiply everything inside of it by 2. So change the value inside the array. I didn't change the variable IQ, right? The rules still hold. I mean, it might take some of you, a few reading through the textbook or listening to this video or tinkering with the code to get the full perspective here, but I did not modify IQ at any point in time. I just used the fact that I knew where to find this object in memory to go ahead and modify it instead. And when I return to the main, guess what? When I use the variable IQ to access the array, well, IQ still point to the same array, is still referring to the same array, but that array has been modified behind my back. So when I display things on the console, again, let me move this guy out of the way here. When I'm going to display things on the console, right, it's going to be the new values that are now displayed inside the main, right? Okay, so just be careful, okay? Yes, everybody says I pass by value when I use value semantic, and I pass by reference when I use reference semantic. Okay, it's an abuse of language, actually. I want to really draw your attention and try to make things, like for a few minutes, I'm going to make things a little bit more complicated and confusing. But the deal is that if you understand what I'm talking about, so take your time, think about it, ask questions. If you understand what I'm talking about, then I will have successfully dispelled a very common source of misconception. Okay, so bear with me. It's going to get a little worse before it gets better. So don't leave me when we get to the worst. Hang with me and we'll get to the better part. So what I'm going to tell you here right now to make you think is there is no such thing in Java as passing parameter by reference. Really, that doesn't exist. What exists in Java is every time I pass an argument to a method, I copy a value. It's whether it is an int value, a long value, a Boolean value, so any other primitive data type, or whether it is a reference, I still copy a value, right? That variable IQ contained a reference. I took the reference, made a copy of it in the parameter A. So it's still the same mechanism. This is what we called value semantic, right? Pass an argument by copying its value. And that seems to be what we do as well when we have reference variable. So what's the deal? Why is there a difference? Because it's the nature of the value that I copy that allows me to do much more. When I copy a primitive data type value, that's it. You have the number 5 on your paper, I have the number 5 on my paper. We are totally independent. But when you have the address of a house on your piece of paper and I have the address of the same house in the piece of paper, if one of us goes to that house and decide to repaint the wall, the next time the other one visits, guess what? Surprise, things have been changed behind your back, okay? So it's the power of sharing references values, but these references are just values. They're copied around. I cannot modify the variable IQ, right, from inside the method, but I can go follow that reference and modify whatever is being referenced. Does that make sense? So take your time. You have to think about this, okay? Again, like I said, we are trying to make things a little bit more confusing so that hopefully you're going to get over that superficial understanding. You're going to get confused, but then once you understand things, then you're going to have a full understanding of exactly what's going on when you call method in Java. And once again, the reading assignment is invaluable to help you understand this. So let's try to make sure that we got it right. Okay, we need to make sure, again, we are in the phase here where almost everybody understands what's going on, but now the problem is you probably understand it partially because it's very easy to do so when you follow those kind of explanation, right? So I want to kind of insist on a few things here up to the point where you really understand everything, every part of the story. So what can we do to ensure of that? We're going to take more examples, okay? We're going to try to apply what we just learned. And more specifically, I'm going to apply what some of you might think they learned that is not entirely correct, okay? So bear with me. I'm going to say, okay, I don't know exactly what that story about, there's only pass by value and everything is passed by value, including reference. Okay, I don't understand exactly what that story is about, but I understand there is passing parameter by value, passing parameter by reference. And when I do one, I can do some things. Again, when I do the other, I cannot do those things. Okay, so now I'm going to consider a method. And that method is going to take two parameters that are going to be arrays, all right? And I want to swap two arrays. So we're going to jump into a graph, and I'm going to show you exactly what I mean here. So we have the same code here that we had in the slide in JGrasp, okay? So a class called swapping stuff, a main method. Here's the A and B that are 735. Before to call swap, I display on the screen what is A, what is B. I call swap, I display again what is A, what is B to see if there was any change. And then here's a swap method that doesn't work, right? The one that I had in the slide. And it tries to do the swap for the parameters, but then it's just swapping the parameters and it's not swapping anything else. So I'm going to comment here and swap method. All right. Compile this first. Let's make sure it works. Run it. There we go. Before A7, B35, 735 after. So I just repeated what we just went through on the slides. Okay. Now what I want to do is I want another method, public static void. It doesn't return anything. I'm going to call it swap arrays. All right. And instead of taking an int A and an int B as parameter, I'm going to say it's going to take an array A of int value and an array named B of int value. So these are going to be reference variable, right? My parameters are reference variable. And swap arrays method. And then inside of here, what I want to do is I want to kind of show you how you may misunderstand everything I just explained, right? So if I understand it wrong, I'm going to say, oh yeah, you know what? These are reference variable. Wow. So that means that inside the main, if I have, for example, let me build up an example here as well of how we are going to call that thing, right? If I have, for example, int eta1 equals 1, 2, 3. It's very simple, okay? And int square bracket data2 equals 4, 5, 6. What I want is I want actually to call a method, and the name of that method is going to be swap arrays. All right. I want to give array data1 that data2, and I want the method to swap them around. And to make sure that it works, I'm going to system.out.print. I cannot type today, sorry about that. That happens more and more often, actually. So system.out.println, and I'm going to say before. That _t, some of you are wondering, this is a tabulation. It's just to put a fixed spacing, not a fixed, a variable spacing after the name before. Okay, if you have a question about that, ask me during office hour. It's not important, just like visual, okay, aesthetic. So before, and I want to display, so I'm going to use that little trick, arrays.toString, okay? Okay, and I want to say array.toString, so give me a string that represents the content of array data1. There you go. All right. So I have all of this here to just display on the screen, the content of array data1. There we go. Let me cut and paste this. And I'm going to do the same thing after. Okay. So after, I'm going to go right here. And I'm going to change the before into after. otherwise that would be a little bit confusing on the screen. And I'm going to say, okay, now let me show you after the swap what I think is going to be a swap that works, okay? And spoiler alert, it's not going to work, okay? But I'm going to explain exactly why it's not working. I'm going to display the content of data one. So I could display only data one. I don't know what I was thinking here. I should display, also data two. So I'm going to be lazy. I'm going to go here and cut this, paste it here, and say, all right, I want data one, and then I want data two. And then same thing here. I'm going to say, I want a space after this, and I want to see the content of data two. I want to see what's in my first and second array before and after I call the swap array, just like I did, with A and B in the example before. So the only thing that I changed is if you look at that setup, okay, the setup here and the setup here, they're the same. Declare some variable in the main, another variable in the main, pass both variable to the method. Hint, hint, in Java, you don't pass variable. I'm using the abusive language here to show that I'm misusing it, actually, okay? So pass those variable. No, actually, I pass the value inside the variable, which is the value of the references, and that's totally different. And then display, whatever happened if there was a modification. And no, there's not going to be any modification. And now I'm going to write the swap array method the same way, saying like, oh, now that you gave me reference, I'm falsely believing that I can swap around the references. So I'm going to try to do that. Here we go, int tmp equal a, and then a equal b equal tmp. So I tried the same strategy that didn't work before, and I try it again because now I say, oh, it's going to work now because I'm using reference parameters instead of primitive data type parameters. Well, let's see how that fares. Control B, let's get rid of all the typos and stuff like that. Cannot find arrays .toString, so I just need to do an import here. Import java.util.arrays, I'm going to guess. There you go. Control B. All right. So let's run it. So the part about A and B being before, after 7 and 35 didn't change. And then here we go. So before my data one array is 1, 2, 3, the data two is 4, 5, 6, and after it's still 1, 2, 3, and 4, 5, 6. So what happened exactly? To show you, actually, I'm not going to tell you, I'm going to show you exactly what happened here. To show you what happened, I'm going to use a debugger. So a different perspective, okay? We saw trace table, we saw drawing by hand, the activation record, how they pile up on the stack and then disappear. Now we're going to do it the way that we are going to do it for the rest of the semester together in COP 2513, which is using the debugger. So I put a breakpoint here on line 11. I want to run this again, but I want to run it this time through the debugger. So I click that beetle icon. So because my breakpoint was on line 11, Java started executing my code, executed all of this, okay, without stopping. Well, that's the point of the debugger, right? I don't want to necessarily stop at the beginning. I can if I want, but I might want to stop, only when things are getting interesting. For example, here, line 11. So my local variable right now are A, which is 7, B, which is 35. So this shows me, okay, on the call stack, the program's execution stack, okay, it shows me the activation record of the main. This is everything in the activation record of the main method. And I'm about to, let's click on that arrow down here. I'm about to declare a variable, local variable data1. There we go. Data1 refers to an object. It's a reference variable. Inside that object, it's an array object, right? There are 3 int values, 1, 2, 3. And then if I execute line 12, now I have data2, which contains 4, 5, 6. Okay? And here I'm going to display, so before, this is the content of my arrays, no problem. And now what's coming up next is swap array. So until now, we talked about the down arrow in the debugger, okay? How you can use a down arrow to step through things. So if I click one time on the down arrow, I'm going to execute line 14. I'm not going to see any detail, and then it's going to show me that, well, the two array didn't change. But I want to understand why they didn't change. So I want to step into. Step through is a down arrow. That means I don't want details. Step into means you are about to execute a statement here. If it's a call to a method, show me what's happening inside that method. Step into the method, and wait. Give me back control. Let me pause execution and see exactly what's happening. So to do that, you use the down and bent to the right arrow. Okay. So step into, click. There we go. So there's a gray arrow here that shows us that we are still executing line 14, actually, to be honest, okay? We are still in the process of executing line 14, but to execute line 14, I had to jump here on line 26 inside the swap array method because I'm executing the swap array method. And now you can see that on my call stack, I still have the activation record of the main. And if I click on it like I did, you see everything that was in the activation record of the main. But now I'm executing swap arrays, and this is a current activation record of the current method I'm executing. And when I click it, you see that I have different arguments. I have argument A and B. These contain reference to the same object that in our main data 1 and data 2 we're referencing. So you can see the content is the same, 1, 2, 3, 4, 5, 6. And then I'm going to have a local variable temp here that I'm going to create. So step through, I don't want details, step through. Temp now is a reference to the same array than the one referred to by parameter A. So 1, 2, 3, 1, 2, 3. You can recognize it like that. Now I'm going to assign B to A. So when I assign like that, I don't make a copy of the array. I just make a copy of the reference that is in B inside the variable A. And then I copy the reference that is in temp into variable B. So you can see that right now, before to execute line 28, okay, both A and B, I'm going to make this a little bigger, A and B refer to the same of the two array that contains 456. 456, 456. It's object 213 in memory. This is object 213. That shows you the 213 is kind of like the reference. It shows you that both variable parameters are referring to the same array. Okay, and then here the temp variable. Look at what's happening here. It's still referring that array that contained 1, 2, 3. So object reference 210. So when I'm done, when I execute the last step, and I'm going to use a down arrow, there we go, then I successfully swapped, okay, in the sense that now parameter A refers to the second array, parameter B refers to the first array. So I did the swapping like I did before. However, once I return from the method, since I modified A and B that has the parameters, right, nothing changed. And I'm back in the main. And data 1, data 2 were not modified. You see that data 1 still contains 1, 2, 3, data 2 contains 4, 5, 6. And when I display them on the screen, therefore, it's still 1, 2, 3, 4, 5, 6. So how is it that I can use that reference trick? Okay, because I'm trying to put you in a situation here where you should be wondering right now. So where are you going with this? Is it working? Isn't it working? You're confusing me. Yes, I'm confusing you so that you understand fully. Okay, what I want to do now is I want to write a version that's going to work, and I want to show you how I'm going to use the property of reference semantics, so the property that stem from actually passing copies of reference values instead of just primitive data type values, okay? I want to leverage that to be able to swap those arrays. But to do so, if I understand correctly how Java works, I need to drop the idea of swapping the two arrays in one step like that. It's not going to fly. What I need to do instead is I need to swap the elements inside the arrays, okay? So let's go back real quick here to our example. There we go, code example. So I'm going to call this swap array bad. Not really original, but I'll try to do better next semester, I guess. Swap array bad, okay. And then I'm going to have another swap array that is actually the good one. So there we go. Here, cut and paste oriented programming for the win. This is bad. This is good. I'm just going to call it swap array. let's not rub it in the nose of the bad method that it's bad and that we are good. So swap arrays, there we go. That's the one that's going to work. Okay, so I need to do something different here. I'm going to change the code in a minute. Here, I want to go back here. I want to stop calling swap array bad. And I want to instead call swap arrays the good version. There we go. The one that's going to actually do something. Please notice I call it the same way. Okay, that hasn't changed. And then what do I do? So swap, I leave it alone. Swap arrays bad, I leave it alone. Swap arrays. So what am I going to do now? Well, now what I'm going to do is I'm going to use the variable int temp. So I'm not trying to swap the two array by swapping the references somehow, because I saw that this doesn't work. But instead, what I'm going to do is I'm going to swap the element inside the array one by one. So I'm going to assume that A and B have the same length. If they don't have the same length, if I'm trying to swap two arrays that don't have the same length, it's not going to work. Okay, if an array has 3 elements and one has 1,000,000 elements, yeah, it's not going to work. But assuming that they have, so I'm going to write it, assuming A and B differ to arrays of same length, and the length of an array is a number of elements, okay? I'm going to do a for loop. So for int I equal 0, I lesser than, so because they have the same length, it doesn't matter if I take the length of A with A or B, okay? Whichever array is going to have the same length anyway, so I'm going to just pick one. And then increment I at the end of every loop iteration. And inside of this, I'm going to say, let me save the value at index I inside the array referred to by A. Let me put instead the value that is at the same index I, but inside of B. And then I will override the value in B by the one that I saved from A. And there we go. This is the end of the for loop as we know it. Control B. Debug is active, yes. Oops. Let's end the debugger. It's compiling without problems. Awesome. And now we're going to run it and see what it does, okay? So before 1, 2, 3, 4, 5, 6, so data 1 is 1, 2, 3, data 2 is 4, 5, 6. After, data 1 is 4, 5, 6, data 2 is 1, 2, 3. So we did successfully swap. So how did it work? Again, the debugger is your best friend. Every time you are trying to understand why a piece of code is behaving in a certain way, okay, don't hesitate to fire up the debugger, okay? So here I'm going to, again, restart this program, but this time with the debugger. So it's still running from the beginning up to that breakpoint that is still left there, okay? You can remove the breakpoint anytime by clicking and then clicking again to put it back. And now I have this data 1, data 2. So we've seen that, okay? So data 1, data 2, this is me declaring those arrays inside the main method. So here's the activation record for the main. Here's everything it contains. So A, B from our original example. Then data 1 is 1, 2, 3. Data 2 is 4, 5, 6. Okay, so this has not changed. I display on the screen. There we go. I skip this commented line here because now I'm going to use a different method, the new one, the new version. I want to see exactly what's happening, right? So I'm using the bent arrow here. There we go. Step into. So I jumped. So again, okay, gray arrow to remind me where I was. Well, there should be a gray arrow here, but for some reason the display is a little messed up. So, okay, never mind. But I jumped inside the code of that method. So I enter that method. I have a new activation record on the stack. It contains what? Parameter A, parameter B. A refers to the array that contains 1, 2, 3. B refers to the array that contains 4, 5, 6. Okay, so far so good, just like before. And then I have this for loop. So let's step through the for loop. So click the down arrow. As I enter the for loop, the first part of the for syntax here declares and initializes a variable I. So while I am inside the for loop, I'm going to have a local variable I that I can use just inside the for loop. Okay, and right now it contains 0. Awesome. I'm going to evaluate if I is lesser than a dot length. So a dot length, the length of the array referred to by A is 3 elements. So is 0, which is I, lesser than 3? Yes. So I jump to line 36. I'm ready to execute line 36. Well, let's go for it. So I have another variable named temp, okay? And I assign what? I assign to temp A index I, with I being 0. So A index 0, there we go. A index 0 is equal to 1. So temp contains 1. So temp contains the value of the first element of the first array. And then look at what happens here. I modify the value of the first element of the first array. I assign to A index I, so I is still 0, right? So A index 0 is assigned B index 0. This is B index 0, 4. 4 is assigned to A index 0, and I lose the previous value here. But luckily, I saved it. I saved it in temp. That's how we swap the content of two variables, right? And so the last thing I have to do then is to say that 4 here, since I stored it here, I copied it here, now I need this 4 to become the one that I saved here. So click on the arrow. This is exactly what's happening. I did successfully swap the content of the first element in the array, in the first array, with the content of the first element in the second array. All right? That's different. I changed what I was referring. The array that I was referring inside my method has been modified. Therefore, the main method that is referring to the same array is going to see the modification. And that's the key of it. That's the crux of the whole thing. If you understand that, if you really truly understand that, not just a superficial understanding, but you're capable to explain it to somebody else and explain to them why does the superficial explanation that I try to sell you are not working, then you're solid. You're solid on references, okay? And don't hesitate to bring tons of questions in Piazza and office hours on that. It's a very important topic. We're going to use references a lot this semester. It's going to get a little bit complicated sometime, probably. So you might want to use this time while we're brushing up on your basic Java skills to make sure that you understand, the basics, the essentials, the foundation of how to manipulate references. All right, and then what? And then I go back to the beginning of the loop, and I'm ready to iterate again. So here we are. I is going to be equal to 1. Inside of temp, I'm going to save the value of I of A index 1. Okay, A index I is 1. So A index 1 is 2, so I'm going to save in the variable temp the value 2. Here we are. So I saved this value here. All right. And then I'm going to override this value with the value of the second element in the second array. So this value is copied here. And then I'm going to copy this value that I saved here. I swapped the second element of the first array with the second element of the second array. And then last turn in the loop, I equal 2, I equal index 2. So remember, an array with 3 elements. The first element is at index 0, the second at index 1, and the last element at index 2. Okay, so whatever the number of element is, the index go from 0 to that number of element minus 1. That's the rule for arrays, not only in Java, in almost every programming language that I know of. So last step here for the loop, temp is now the value of that element here, the third element of the first array. I save that value. I overwrite this value with the value of the third element of the second array. So I have a 6 here and a 6 there. And then I overwrite this guy by the value that was in the first array to start off with. So I have a 3. And now, is I lesser than a.length? So I is equal to 2. Okay. I'm going to, at the end of my loop, I'm going to increment I by 1. And then I'm comparing, is I lesser than a.length? So a.length is going to be 3. So is it lesser than 3? It's no longer lesser than 3 once I'm done incrementing it. And I get out of the loop, I reach the end of the method, and now I'm ready to return back to the main. So this activation record here is going to disappear. But if I click on the main's activation record, right, I have data 1 referring to object 620 and data 2 referring to object 621. Well, let's go back here These are the exact same object that parameters A and B have been referring all along. These are the same arrays. We share the array between the main method and the method that was called. So as a result of that, when I reach the end of my method here and I return to the main, you see that I lose the activation record for that method. So I lost all of those I, temp, A and B parameters. All of that was wiped pretty much, but I'm back in the main. And because I modified the content of the objects that were referred to by data1 and data2, there we go. Now when I display on the screen, it's going to show that the arrays have been swapped. Okay? So we have if my timekeeping is right, we have about 5 minutes. So what I want to do is get you something to think about between now and the next lecture. So I want to show here one more slide. And I'm not going to run through the code, but I'm going to kind of guide you and give you some hints on how to think about this. So I illustrated that, the basic approach that didn't work in Java to swap two primitive data types doesn't work even when you have reference data type. It's not because you have reference data type that it magically works. We have to do something special. We have to use what reference are good at, which is giving us access to an object that is shared with whoever called us. So we use arrays to illustrate that because everybody knows arrays. Everybody uses arrays, and they are pretty much the same in most of the programming language that you are going to find in an introduction to programming. But now, here's what I suggest we do. To confirm that we understand, again, what's happening when we use reference data type, let's use a different reference data type. Well, we don't know many of them. Okay, we know scanner, we know string. So we're not going to mess around with scanners. That would not be really good for this kind of example. We're going to mess around with strings. So what if I have two strings, one that say hello, one that say goodbye in the main, and I want to call a method called swap strings, and I pass the name of the two variables that refer to hello and goodbye, and I want to pretty much have this variable content swap. Well, by now you should know that this is a trap, right? We cannot do that in Java. We cannot do it with primitive data type. We cannot do that with reference data type. But what I could do is I could use the fact that I pass the reference to two string object to my method and have this method go inside the string object and permutate the element inside, which are the character one by one. So would version 1, swap the reference work? No. But try it. Try to implement it, debug for it, so that you see exactly why it's not working. And if you're not 100% sure, ask. Okay, trust me, this is kind of like a hard pill to swallow for our third week of class, right? So now, what about version 2 that I had in the previous slide, the one where we finally successfully were able to swap the content of the array by going into them, and swapping element one by one. But if I try to do that with strings, what's going to happen? Well, this is where it's kind of more of an open-ended question. Okay, so I'm going to let you, at this point in the slide, I'm going to let you try to experiment it. But I would also suggest that you pause the video so that I don't spoil it completely, because I'm going to spoil it, of course, very soon, in a few seconds. Try to do it and let me know in the Piazza or whatever. Let me know, or let the TA know, whoever is there. Let us know what you are missing, what you are not finding when you are looking at the textbook chapter on strings and all the methods that are available to play with strings. What's missing that prevents you from being able to swap, let's say the first character of the first string with the first character of the second string, just like we did swapping the first element of the first array with the first element of the second array. It's not going to work with strings. Actually, spoiler alert, we don't have methods to really allow us to do that. Second level spoiler alert. The textbook should say somewhere that strings are immutable. What does that mean? All right, last level spoiler alert. Pause the video if you don't want to have the whole solution right now. So when you are going to try to do this with strings, okay, what's going to happen is that you're going to realize that there is a method in the string class that allows you to, it's called char at, character at. You call it on a string and you say, I want the character at index 3. So with hello, H is at index 0, is at index 1, L is at index 2, L is at index 3. There we go. That would give me the L. So I can go inside a string and read the value of the character at index, whatever I want. But what about assigning a new character, replacing that lowercase L from hello, for example, by an uppercase L? There's nothing to do that. You cannot change a character inside a string. You cannot change any character inside any strings. The string that we are using right now in Java from the class string are what we call immutable. That means that once you create it, once you say I have a string that says hello, you can never, no matter how many different reference variable have the reference to that string, you can never actually go inside of it and change any of the character that are there. That makes it very safe. That makes that if you and I are sharing a string, for example, then I know that you're not going to change the values of the letter behind my back. So by the time I display it, I know I'm not going to display something completely outrageous, for example. Okay, so it's a difference at that level. What we are observing here is it's not a difference in the way value semantic works. It's not a difference in the way of what we can do with references theoretically. It's just a difference that when you have a reference on an array, the array allows itself to be modified via its reference, okay, through its reference. When you have a reference on a string, the string class doesn't allow anybody to modify the content of the string once it has been set. So you see, we have like 3 levels, right? With the value semantic. Then the value semantic applies when we pass a reference, which are just special type of value, but we can do more with reference. We can access the object, but then it depends on what kind of object we are accessing. And sometimes some class are going to let us do whatever we want, and some class are not going to let us do whatever we want. These are all topics, don't worry, these are all topics that we are going to drill down for the upcoming weeks. Okay, but I wanted to take that review of Java fundamental and stretch it over the hardest part of COP 2512, the things that are technically, the most difficult to understand. Make sure that everybody got exposed to those parts, because it's really easy to do an introduction to Java, a first programming class, and skip over all those things that are a little bit more complicated. Okay, well, they go a long way in explaining, why programs behave the way they behave. And when you have a bug, the only thing that can save you is to know exactly what Java is doing with your code, right? So we cannot really skimp around and be skipping too much about the fundamentals of how Java behaves, right? So I want to make sure everybody's on the same page. This is meant as a conversation starter. This whole lecture is meant to pretty much confuse you, clarify, confuse again, clarify, and now you think you have it, but hop, it's escaping again your grasp, and then finally we catch it, right? And if you go through that process, trust me, you will have a rock solid foundation on manipulating reference, which is going to come very handy this semester. So make sure, again, office hours, you know the drill, Piazza, don't let that slip by. This is a milestone. This is a very important milestone in our course that we are reaching right now. We are finishing the review of Java Fundamental. I stretched it to things that are going to be used all semester long in COP 2513. So make sure that you're on board with me for this transition, okay? And if it's hard, don't worry. We're here to help you guys. All right. Well, thank you everyone for your attention, and I'm going to wrap it up for this video.